In this video, we're going to be reviewing the segment addition postulate. So the key question we have is, what even is a postulate? We've never heard this term before. So a postulate is just a given statement, and so it does not require any proof. So it's something that we can rely on in geometry. So the one thing that we want to remember, we kind of talked about this last time, but a line segment is a segment that has two endpoints. Remember, it looks like this. So it has a defined length. We can measure it. We can either call this segment AB, that's how we pronounce it, or we could call it AB with the line over it. That's how we say segment AB. So to find the measure of segment AB, the only thing we have to write is just the two letters AB. So what I mean by that is, if I took a ruler to this segment right here and I measured it, I could say that AB, or the measure of AB, is 3 inches. When I'm just identifying that this is called segment AB, I need to label it with the segment symbol. If I'm just calling or setting it equal to a number to say what it measures, I can just say the two letters. So the actual segment addition postulate tells us that if point B, so this point, is between A and C, that is true if and only if points A, B, and C are collinear. So remember, collinear means they lie on the same line. And we have to know that AB, so the measure of AB, plus the measure of BC will equal AC. So if these two segments add up together to equal the length of AC, then that is true. So we know that point B would be between A and C if those two measurements add up. They also need to be collinear. So that's what our segment addition postulate tells us. So we use that to solve a bunch of different problems, and we're going to do a lot of examples on the second page here. So if you feel like you understand it, go ahead and pause and try them on your own, and I will review all of them. So I'm going to zoom in to go over our first question, and it said, if BC equals 7 and CD equals 11, then what is BD? So we're talking about the distance from B to C, so that measure is 7, and the measure of CD is 11. We're trying to solve for what the entire length of BD would be. So we use the segment addition postulate, and we know that BC plus CD, so this segment plus this segment, will equal the length of the entire segment. So it would equal all of BD. So then we can plug in the values that we know. So BC is 7, CD is 11, so all of that will equal BD, and so 7 plus 11 gets us 18. So the entire length, or the measure of segment BD, will be 18, and that is our final answer there. In the next example, we have if the measure of ST equals 12 and the measure of SU equals 20, then what is the measure of TU? So this time we're given ST and we're given SU. We're looking for the measure of TU, which is this distance here. So you can call that a variable. I'm just going to call it TU because that's the name of the segment. So based on the segment addition postulate, we know that ST plus TU will equal all of SU. And again, we're just going to plug in what we know. So ST is 12, we add it to TU, and all of that will equal SU, which is 20. And then I can just solve this like an equation. So to get TU by itself, I would just subtract 12 from both sides, which would leave us with TU equals 8. That's our answer, and we can actually go back and check that to make sure that we got it right. So if I do that, I would be checking and plugging in ST was 12, plus TU was 8, and that should equal all of SU, which is 20. And we know that 12 plus 8 does equal 20, so we got it right. In our next example, we had if the measure of EF equals 2x, the measure of FG equals 6x, and the measure of EG equals 8, then what is the measure of FG? So this time we have some variables in here, so we actually have 2 steps to complete to get the final answer here, rather than just doing what we did above. So we can tell by the segment addition postulate that the measure of EF plus the measure of FG will equal the entire measure of EG. And then we're going to plug in the values that we know. So EF is 2x, FG is 6x, and EG and sorry, I filled that in incorrectly. So we know that EF is 2x, we know that FG is 6x, and EG is 8. I did fill it in correctly, sorry. 2x plus 6x is 8x equals 8. We solve for x by dividing by 8 on both sides, so x equals 1. We're not done though, because the question asked us what is the measure of FG. So FG was given to us as 6x. Well, now I know that x is 1, so I just evaluate it when x is 1. So FG equals 6. We can go back and check this to make sure. If I plug in 1, that would be 6 times 1, so that was 6. If I plug in my 1 for x for this one, we know that this was 2. So that would be 2 plus 6 equals 8, and we got that right. In our next example, we have the segment measure of ST is 4x. The measure of segment TU is 3x, and the measure of segment SU is 7. So they ask us to solve for TU. We know it's 3x, but we want an actual value, so we need to solve for x and then evaluate for x. So we know that the segment addition postulate tells us that the measure of ST plus the measure of STU will equal the measure of SU, and then we plug in the values that we know. So ST is 4x plus TU is 3x plus SU, or equals SU, which is 7. We solve, so we get 7x equals 7. So that means that x equals 1 again. But we are not done because they asked us to solve for TU. TU is given as 3x. We evaluate TU for when x equals 1. So TU equals 3. We can double check that we got it right. We know that this is 3. We can evaluate 4x when x is 1, so that's 4. And then that tells us that ST, so 4 plus TU of 3, 4 plus 3 is 7, and that was the length of the entire segment. So I'm going to show you the next 3 problems and give you a moment to try to solve them. If you'd like to press pause and give them a try. All right, now that you've tried the problems, we're going to go over them. So in the first one, we see that in the diagram, M is the midpoint of the segment. So we need to find XM, which is we're looking for the measure of it. So because M is the midpoint, it isn't a word we've talked about, but we can kind of figure out what a midpoint would be. It's that halfway point between 2 points. So because M is halfway between these two, we know that XM, or the measure of XM, will equal the measure of MZ. That's what the midpoint tells us. So because we know that, we can plug in these values for XM and MZ. So XM is measured as x plus 2, and we can set that equal to MZ, which is 2x minus 3. We're going to solve this equation to figure out what x is. So I'm going to subtract x from both sides. I get 2 equals x minus 3. I add 3 to both sides. So I get 5 equals x. Now we're not done because the problem asked us to find the measure of XM. XM was given to us as x plus 2. So we're going to evaluate it with our new x value of 5 that we just solved. So XM will equal 7. That's great, but let's double check to make sure we got it right. We can check to know that this is true because we know that MZ should also be the same as XM because it's the midpoint right there. So we can evaluate for MZ, and that would have been 2x minus 3. We plug in our 5 for x. That gets us MZ equals 10 minus 3. So MZ is also 7. Because we got 7 for MZ and XM, we know that those two segment lengths are both congruent there. And so this was truly the midpoint and we solved it correctly. So XM equals 7 was our final answer there. In the last 2 examples, it's going to be very helpful to draw a picture for yourself. They're telling us in the given statement that points A, B, and C are collinear. Point B will be between point A and C. So I'm going to start by just drawing a diagram for us. We have point A, point B, and point C. Now I'm not drawing this to scale, so it might look like it's the midpoint, but we're just going to use the values that are given to plug them in. So AB equals 13 is my first segment, so I'm going to plug that in right here. And then they also tell us that BC equals 9, so that's this length here. We are looking to find what AC is. We know based on the segment addition postulate that AB plus BC will get us the entire length of AC. So I'm going to plug in 13, I'm going to plug in 9, and I'm going to solve for AC. 13 plus 9 gets us a length of 22 for the measure of AC. Now we have that similar setup in our next example, but it's a little bit more challenging because we have some variables involved. So I'm going to zoom in a little bit on this one so we can see it better. And again, we're starting with the given that A, B, and C are collinear and that B is between A and C. So I'm going to color code again to help us see this. We know this time that AC, so this entire length here, is going to be 3x plus 3. The next part of the segment, AB, is given to us as -1 plus 2x, so that's this segment here. And then our last length that was given was BC, and that was given as 11. So using the segment addition postulate, we know that AB plus BC will equal AC. We're going to plug in the values that we have. So AB is -1 plus 2x, BC is 11, and AC is 3x plus 3. I'm color coding this to help you see which sections I'm adding from those lines. I'm going to then go ahead and solve this. So I'm going to combine like terms, and I get 10 plus 2x over here equals 3x plus 3. To solve that, I need to get all my variables on one side, so I'm going to subtract 2x from each side, and then I'm going to subtract 3 from each side, so I get 7 equals x. I'm not done because the problem asked us to solve for AC. So AC was given to us as 3x plus 3, so now I'm going to evaluate that for when x is 7. When I do that, I get 21 plus 3, so AC equals 24. Now you can go ahead and check this by solving for that other segment that was up there. AB was given to us as -1 plus 2x. When I evaluate it for x is 7, I get -1 plus 14, which is 13. So we know that AB is 13. If that is the case, then we should say 13 plus our segment BC, which was 11, should equal our whole segment AC, which we solved for as 24, and that is a true statement, so that's how we can confirm that we got that answer right for AC. Thanks for watching.